Hello everyone, welcome to our first discussion for the course Hardware Software Installation. This includes the phase 1, which is the fundamentals of PC hardware and software. So topics includes the introduction, the evolution of hardware devices, hardware components, main boards, processors, clock, memory hierarchy, the main memory, the secondary storage, and the buses. Now, the objective for this topic, after reading this chapter, you should understand hardware components and must be managed by an operating system, how hardware has evolved to support operating system function, how to optimize performance of various hardware devices, the notion of an application programming interface, and the process of compilation, linking, and loading. So, introduction. An operating system is primarily a resource manager. It is designed to the hardware and software resources the operating system must have to manage. The first is the processor. Next is the memory, secondary storage, other I/O devices, the processes, the threads, the files, and databases. So as we all know, that operating system is part of the software which is considered as system software. It is called an operating system because it is responsible for operating and managing the hardware and the software communication, because hardware is nothing, software is nothing if there is no operating system which will facilitate the communication from each other. So operating system is a very important software that must be installed in your hardware in order to perform its function as computer system. So the evolution of hardware devices. Most operating systems are independent of hardware configuration. Independent in the sense that it is not very concerned on what particular hardware are you using, but it is actually focusing on the understanding between the hardware and the software when it comes to processing the data. Operating system use device drivers to perform specific I/O operations. Okay, the operating system is having a drivers or is facilitating drivers for the communication of a particular hardware being installed to your system. Let's say, for example, when you are going to plug in a particular device like the camera, the scanner, the printer, those devices has its own drivers, and that driver should be installed into the system first in order for the operating system will let the hardware recognize the presence of that particular device. So that is the purpose of an operating system also. For example, plug and play device when connected and instruct the operating system on which driver to use without user interaction. So at this time, when we plug our devices, it is automatically being installed, or there will be a confirmation from the user to continue installation of the driver. Okay, because failure to install the driver of a particular device, the device that is connected to your system will not be recognized. That is one of the features or function of the operating system. So operating system have different components. The components of an operating system play a key role to make a variety of computer system parts work together. So the operating system components are discussed below. So in this figure, these are the different components that are found in the computer system. So hardware devices, the device driver, the file system, the APIs, the kernel, and the user interface. So let's talk about kernel. What is the kernel? A kernel in the OS provides the basic level of control on all the computer peripherals. So when we say that the kernel is responsible for controlling everything in the process of the hardware and the software processing. So in the operating system, the kernel is an essential component that loads firstly and remains within the main memory so that the memory accessibility can be managed for the programs within the RAM. It creates the programs to get access from the hardware resources. Okay, so that is the role of the kernel. The kernel is responsible to oversee everything what is going on in the process of the computer system. Process execution. The operating system also gives an interface between the hardware as well as an application program so that the program can connect through the hardware device by simply following procedures and principles configured into the OS. Okay? As we all know that the computer system is actually composed of hardware, software, and the user. Okay, so the operating system that belongs to the software, which is considered as the system's software. Okay, the operating system gives an interface between the hardware, how the computer can communicate with the software, and how with the software can communicate with the hardware. That is by means of the operating system that serves as an interface and mediates the communication between the two peripherals. Okay, so the program execution mainly includes the process created through an OS kernel that uses memory space as well as different types of other resources. So the operating system has the control of the execution of all parts of the computer system, communication with the different software installed in the system. Interrupt. And the operating system, interrupts are essential because they give a reliable techniques for the OS to communicate and react to their surroundings. So the interrupt is nothing but a kind of signal between a device as well as the computer system. Otherwise, from a program in a computer that requires the OS to live and decide accurately what to do subsequently. So the interrupt is something that is a control or a signal between the different devices on what particular action should be done, that is still based on the instruction that is coming from the programs. Memory management. The functionality of an OS is nothing but memory management, which manages main memory and moves processes backward and forward between disk and main memory during implementation. Memory management, the operating system has the capacity to check, allocate memory for a particular process of data. As we all know that processing of data in a computer system that is actually requiring memory allocation. So in the case that your memory is encountering problem, there might be effect to your hardware. So maybe your system becomes slower in terms of processing, or worst is it will not store or process your data or application. So that is one feature of the operating system, that is to manage memory allocation from one device to another. Okay? So multitasking. Multitasking, it describes the working of several independent computer programs on a similar computer system. Multitasking, from the word multitask, meaning it can perform several tasks, but the operating system is trying to make sure that there is no overlapping. Everything is doing fine and there is no problem when it comes to the execution of the instruction. The operating system has the capability of facilitating the process in an orderly manner. Multitasking in an operating system allows an operator to execute one or more computer tasks at a time. Since many computers can perform one or more tasks, usually this can be done with the help of time sharing, which each program uses the time of a computer to execute. Networking. Networking can be defined as when processors interact with each other through communication lines. The design of communication network must consider routing, connection method, safety, the problem of opinion, and security. So in the term, when it comes to networking, operating system also has specific features that will have to manage the network communication, like routing, the connection methods, the safety, and other problems that may arise. Operating system has the capacity to handle those problems. Security. If a computer has numerous individuals to allow the immediate process of various processes, then the many processes have to be protected from the other activities. It is very important. Security is very important, especially in our data. So operating system has also that features that will have to make sure that your system is protected. It will not be easily the data will be protected from outside interference. So current operating system give an entry to a number of resources which are obtainable to work the software on the system and to external devices like networks by means of kernel. So user interface. A GUI, or graphical user interface, or UI, is part of the operating system that permits an operator to get the information. That is, to get the information by means of the user interface. That is what we could see in our monitor, that the different icons which enables us to click the buttons, the icons, that is for a specific purpose of processing. So that is what you call user interface. The OS-based application mainly provide a specific user interface for efficient communication. So the main function of a user interface of an application is to get inputs from the operator and to provide outputs to the operator. So that is vice versa. The user interface allows us to click, allows us to display something that is depending on what particular purpose is that interface for the end user. So in here, we have the evolution of hardware devices. So it is talking about the different transistors. So this is coming from 1970 up to 2005. It is not really that updated, but that is the image or the graph that shows the transistor count plotted against time for Intel processor. So as the time or as the evolution of the hardware devices at present, it is too different from the devices or the hardware devices before. So nowadays, inventors are trying to make the performance of the different hardware devices as fast and accurate. That is to address the needs of the user. Hardware components. The computer hardware consists of the processor, the main memory, the input and output devices. As we all know, that computer system is composed of hardware, software, and user. So we talk about the hardware components. Processor. Processor is considered as the brain of the computer system. It is responsible for processing all of the instruction that is fed by the user. The main memory. The main memory is concerned with the data and instruction that is being fed by the user, and that will handle everything in terms of data. Input and output devices, these are tangible objects. These are referring to the peripheral devices that is attached to the computer in order to perform the specific task. It's either to input data or output data. We all know that computer hardware has the monitor, has speaker, has other devices like projector that is considered as output devices. Input devices are like microphone, mouse, keyboard, and others. Camera. So those are input devices. And those devices, as we all know, that the devices are actually driven by a particular driver to communicate with the hardware, different hardware, and the software of the system. Mainboards or the PCB, or when we say the motherboard, the hardware component that provides electrical connection between the devices. Our motherboard or the main circuit board is the most important part of the system. Okay? Devices such as processor, the main memory are attached. So this is where the main board is a circuit board, which all of the vital parts of the computer system are actually attached. Let's say, for example, our memory, our processor, our hard disk, and other input and output devices are actually attached. This includes chips to perform low-level operations, example the BIOS, basic input-output system. And then we have here the processor. A processor is a hardware that executes machine language. So all of the language, like higher level language, like our programming language and other applications made through high level language, is actually converted into a machine language. What is that machine language? The machine language are the language that are understandable by the computer system, which is represented by a number 0 and 1. So all of the language or all of the data that is being processed is actually converted into a number zeros and ones. The CPU executes instruction of the program, or the central processing executes the instruction of the program. The coprocessor executes special purpose instruction. Example is graphics or audio coprocessor. So this is actually referring to devices that are attached to your system or to the system board, which will boast the graphics or the audio of your system. Registers are high-speed memory located on processors. Data must be in register before the processor can operate on it. So in the process of machine cycle, or in the process of data processing, all of the data or instructions will be loaded to the registers before the processor can process. Since we all know that the processor will have to process million times per second, that is why all of the instruction and data will be passed to the register first before processor will do the processing. That is to accommodate the speed of the processor, since the secondary storage and the main memory are quite slower compared to these registers. Data must be in the register before processor can operate, and the instruction length is the size of the machine language instruction. So some processors support multiple instruction length. Okay. So processor figure 2, the processor components. So this is an illustration of what are the different components of the processor. A processor is actually considered as the brain of our computer. Okay, we have here the ALO. ALO stands for Arithmetic Logic Unit. So this particular component is responsible for executing arithmetic or logical operation of the data. Okay, there are only two processes that the processor can process: logic, which is comparison, decision making; arithmetic, which is performing mathematical operations. So that falls on the execution unit. Registers, we all know that registers is faster compared to the main memory or the secondary memory. So registers, all of the instructions will be loaded to the register first, then that will be passed to the ALO for processing. Okay, fetch and decode unit. So all of the instruction from the L1 to the cache will be fetched and will be decoded into a machine language before loaded to the ALO for the execution, because ALO will have to perform its execution unless and until the data is being converted into a machine language. Okay, so bus interface, this bus interface are actually where the data is passing from and to. Bus interface. Okay, so this is a kind of wires which the data are actually passing from and to, like for example from the keyboard or from the mouse will be sending instruction to the system, then that is considered bus interface. Clocks. So computer time is measured in cycles. One complete oscillation of an electrical signal provided by system clock generator. The processor speed are measured in gigahertz or billions of cycles per second. So the purpose of the clock is to synchronize the process of an instruction. Okay, that is connected also in the operating system, that the operating system has a timer that is trying to synchronize the process. So the memory hierarchy is a scheme for categorizing memory. So fastest and most expensive at the top, lowest and least expensive at the bottom. So here the fastest is the registers. Next is L1 cache, L2 cache, and the main memory. So the process actually of processing the instruction from the user to the processor, the user will have to feed instruction that will be passing to the main memory, and then that will be passed to the cache registers. Okay, and then before will be passed to the processor. Okay, why is it that it will not go directly from the main memory to the processor? Because the main memory could not accommodate the speed of the processor. That is why all of the instruction will be stored to the register. That is to accommodate the speed of the processor in terms of processing. So secondary and tertiary storage. So these are the example of storage devices like compact disc or DVDs, floppy disk that was before. So main memory is the lowest data referenced directly by processor. Volatile or volatile. It loses its content when the system loses the power. One example of this volatile is the RAM. Okay, random access memory. Random access memory will have to store data, all of the processing from and to the computer system to the processor, but after the system loses power, everything will be lost. That is an example of volatile. Okay, memory hierarchy. So this is now the figure of the hierarchy of the memory from the lowest, which is coming from the hard disk, the tapes, the CDs, the DVDs, to the memory, the main memory, DRAM, DDR, ROM bus is DRAM, then LCache, SRAM, and then the registers that is going to the ALO. So the main memory consists of volatile random access memory. So random access memory, this is a small part of the motherboard. This is actually we're going to place inside the slot that is for storage, temporarily storing the instructions and the data for processing. So processes can access data location in order, and common forms of RAM includes dynamic random access memory or DRAM. So it requires refresh circuits. Then static random access memory or SRAM does not require refresh circuit. These are the two difference between the DRAM and the SRAM. So the bandwidth is the amount of data that can be transferred per unit of time. So the secondary storage stores large quantity of persistent data at low cost. So accessing data on hard disk is lower than main memory. But as we all know that hard disk is very important also because all of our programs are being stored in our hard disk. So these are considered as non-volatile. Okay, so hard disk is more important. This is where we're going to install our operating system. Okay, mechanical movement of read-write head, rotational latency, transfer time. So removable secondary storage facilitates data backup and transfer. So as we all know that there are a lot at the present, there are a lot of secondary storage media which offers large amount of data that can be stored. One of the example is the external drives. Okay, another is universal serial bus disk or USB disk. Okay, disk drives. Okay, DVDs, zip disk, floppy disk, flash memory cards, tapes. So these enumerated are examples of removable secondary storage. But as of the present, they are not very useful because we have already our USB and external drives that serves as our secondary storage devices. Buses. Bus is a collection of traces. Traces are thin electrical connections that transport information between hardware devices. So, let's say for example, if we're going to open our computer system inside, we could see different cables there. Okay, there are a lot of cables that are trying to transport information. Okay, trying to transport information. So that is what you call bus. A bus is actually where the data is passing from and to, from one devices to another device. That is a bus. Okay, so let's say for example the hard disk is connected by a bus which is plugged into the motherboard. That is for the data can be transferred from your hard disk going to the motherboard for processing, and that will be passed to the memory going to the processor and vice versa. Okay, an I/O channel is a bus shared by several devices to perform I/O operation, handle I/O independently of the system's main processor. Example, the frontside bus connects a processor to main memory. Okay, so that is one example of a bus. So I guess that would be all for the first part. I have here the question for our first discussion. What is the role of an operating system in computer system? You are going to answer this. And the number 2 is briefly explain components of an operating system. One is kernel, 2 is process execution, 3 is interrupt, 4 is memory management, 5 multitasking, 6 networking, 7 security, and the last is user interface. So just simply explain and if possible to elaborate, just give a simple example that will relate to what has been asked to explain on the different components of an operating system. Then, what is the function of computer time in the process of instruction? Next, number 4 is what is the role of bus in computer data processing? And the last is give at least 5 secondary storage media. Okay, so the phase 2, we will be talking about the safety precaution. Safety precaution is very important, especially when dealing with electronic devices or in working with the laboratory facilities. Okay, so we are going to have to observe the different 5S in the laboratory. Okay, the 5S is a method used by quality professionals to organize their workplace, predominantly in mechanical industry. 5S method stresses on a simple concept, a place for everything and everything in its place. Okay? A place for everything and everything in its place. Can this be implemented in the IT industry to organize the computer system, files, and folders? This can be applied in our computer system. This can be applied in the physical laboratory areas. Okay, that is why it is very necessary that we are going to observe 5S to avoid accident. Okay, safety precautions. So the first S is Siri or sort. Sort, which means only store important files in your computer. Create folders and subfolders to organize important data. Name folders and files appropriately for easy retrieval. Then create one folder name, say trash, to store temporary data. Clear the contents of trash folders regularly if possible on a daily basis. So this particular figure is showing sort. Okay, how are we going to sort everything in our workplace? Of course, we're going to arrange according to its function, arrange according to its uses. Okay, so we are going to have separate materials or equipments according to its function. Okay, that is one S, the first S in our workplace. Next, set on or set in order. Set in order ensure easy retrieval of data. Create only 2 main folders, one for storing data for frequent use and the other for rare use. Create multiple subfolders to store particular data type or type of data. Limit subfolders at the next sublevels to less than 5. So in physical arrangement, set in order should be, there should have a classification. Okay, let's say for example, you are inside the stock room. You are going to separate those devices that are functional and not functional. That is still based in according to its usage and function. Okay, do not mix everything. So set in order meaning everything is in proper order. When you are going to look for something that is for that particular purpose, you have a specific target then that would save time for you. Next, shine. So clean up unnecessary data in irregular intervals. So in this particular figure, shine refers to after performing our laboratory activities, make sure that everything is in its place. Make sure that before leaving our laboratory area is clean and in order. Okay? Do not leave anything which is not in place. That is shine. So meaning we are going to clean the area before leaving. It is also applicable in our different houses. We have to maintain the cleanliness in our surroundings and our rooms. The advantage of that is if that is clean, there is a less opportunity of encountering accident. So we have to let the workplace shine. Next is shikitsu or standardized. Okay? Standardized meaning integrate storage, retrieval, clean up task, create unified process. So make a habit. Make it a habit that every time that you're going to perform a task, making some activities, you have to perform, set and order, shine, and sort. That is to standardize the process. So it is not only that you are going to perform the 3S just for 2 to 3 weeks, but you are going to perform that every time that you have work in your laboratory or in your personal residence. Okay? So create a version control process document that details naming, structuring, and maintenance schedule of files. Okay? Make sure that, let's say for example, if you are handling different tools, the different tools should have proper labeling. The area should be placed accordingly. Then next is sustain. Track and monitor to adherence to the above 4S by self and peers. Conduct monthly audits, self and for peers, to ensure that the set procedures are followed diligently. Sustain meaning we are going to maintain the process. Maintaining the process would be the best practice for all of us working in, especially in the laboratory areas, laboratory works. Let's say for example, if we are going to troubleshoot computers, make sure that everything is in place. So not just for that particular time, but every time that you are performing troubleshooting and other activities. So that is what you call sustain. So 5S can serve a handy tool for efficient data management of files and folders created by stored users and stored by users. So with the use of computers, data cleanup and data fragmentation tools, system and other unnecessary temporary files and folders can be cleaned up. That is referring to the software side. So fragmentations, defrag. We need to defrag our hard disk sometimes. Okay? We need to clean up our system. That is to maintain and remove unnecessary files. Okay? So that is the purpose of 5S. So every time that we are going to work we're going to perform troubleshooting, especially we're talking about hardware and software installation. So when we are going to troubleshoot our computer system, make sure that everything is in its place. Make sure that everything is properly arranged. That is for the purpose of avoiding accident that may happen during the performance of the activity. So your activity is you're going to explain its 5S in the workplace by giving concrete example on how to perform. Okay? You're going to have set and order, shine, sort, sustain, and other. And then just by giving example, concrete example, how are you going to perform this S? Then think of a scenario related to computer operation which apply 5S in the workplace. And the last is, what is the importance of 5S in the workplace, especially when performing computer laboratory and troubleshooting? So that would be all for this activity. We'll be having more topics to be discussed in the next video. I hope that you learn something, and then by learning something, apply that in your real life so that you can relate what is being discussed in this particular topic. So that would be all. Good afternoon and stay safe, everyone. Thank you.